A product part process passes inspection, and the parts themselves meet the specifications. But somehow, customers still end up with faulty parts. How does that even happen? Have you ever wondered about it? The answer lies in something that many teams tend to overlook: process capability. Today I will explain about process capability. Welcome to Engineering Explained Simply. In my last video, we dove into why products can fail even after they've been tested. One of the biggest culprits? It is this: testing and inspection do not really predict what is going to happen tomorrow. That's where process capability steps in. Inspection shows what's already happened. It's like glancing in the rearview mirror while driving. Useful, but not the full story. Process capability, on the other hand, gives you a glimpse into the future. It tells you what's likely to happen, day after day, shift after shift. So, what does process capability really answer? It boils down to a simple yet powerful question. Can this process consistently produce parts that meet specifications over time? Not just once or during a sample inspection, but consistently. Think of it like driving. The speed limit is your specification, right? Your driving behavior represents the process. If you sometimes speed or drive too slowly, even if you passed your driving test, you're still a risk on the road. Cp and Cpk help us understand just how controlled that driving really is. Let's break it down. Cp stands for process capability. It tells us about the potential capability of a process, assuming everything is perfectly centered. So, if everything goes right, is this process capable? That's what Cp is all about. Possibility, not reality. Now, Cpk stands for Process Capability Index. This one tells us what's actually happening. It takes into account how much the process varies and where the process average really is. This is where a lot of quality problems like to hide. A process might look good on paper, but that doesn't mean it won't produce bad parts in real life. Let's walk through a simple, real-world example to make this clearer. Imagine a supplier producing a plastic housing for an assembly. The specification is plus 0.5 millimeter. They run a capability study, and Cp looks great. Initial samples pass inspection, and the production part approval process, PPAP, gets the green light. Production kicks off, and everyone's feeling good about it. But over time, things start to shift. Material batches vary slightly, tools begin to wear down, and temperatures change between shifts. Nothing dramatic happens, nothing that immediately fails inspection. But the process starts to drift, and that's when the trouble begins. Here's what happens financially. 2% of parts now require rework and 1% escape to the customer. Assembly time increases, and customer complaints start rolling in. Let's break that down into dollars and cents. You've got rework labor costs, scrap material, extra inspections, line downtime, customer returns, and a loss of trust. It's not a massive recall or a major failure, it's just those small capability issues quietly draining profit. This is the real cost of poor process capability. It doesn't explode, it leaks. And this is a critical point to remember. Inspection finds defects after they happen, and testing checks assumptions just once. Neither of these controls the process. You can't inspect quality into a product. You can only control the process that creates it. That's why process capability isn't just a report, it's a warning system. Now let's talk about improvement without getting bogged down in formulas or statistics. Here are some tools actually used in the industry. 1. Control charts. These are your best friends when it comes to monitoring processes. They help you see when a process is stable, when it starts drifting, and when action is needed. They catch problems before parts go out of spec, saving you a ton of headaches down the line. 2. Standardized work. A lot of variation comes from people, not machines. Having clear work instructions, consistent setups, and defined inspection points can help minimize that variation. Less variation equals better capability. Simple as that. Then 3. Tool and equipment maintenance. Worn tools don't just fail suddenly, they degrade slowly over time. That's why planned maintenance is so crucial. It keeps your process centered and running smoothly. Material control. Material variation is one of the sneakiest hidden drivers of poor CPK. Consistency from suppliers, incoming checks, and material change control all directly impact capability. You've got to keep a close eye on this. In ongoing capability monitoring. Capability is not one and done deal. Processes change, conditions change, and if you're not monitoring capability, you won't know when risks are creeping up. If you remember just one thing from this video, let it be this. Inspection finds defects, testing checks assumptions, and process capability predicts the future. CP shows what could happen, while Cpk shows what's actually happening. And when capability is poor, the impact isn't just technical, it's financial. In the next video, we'll dive deeper into that financial impact, the real cost of poor quality, with a clear, simple case study. If this helped you grasp process capability a bit better, give it a thumbs up, subscribe for more engineering insights, and drop a comment below. See you again in next video of Engineering Explained Simply. Thank you.